Welcome to the deep dive. Today we're taking a look at the core factual differences between commercial and residential HVAC systems. Now, on the surface, you might think all heating and cooling units do pretty much the same job, right?
hmm
But when you start to explore the details, the distinctions are really quite significant. And understanding them, well, it gives you a much clearer picture of the engineering and considerations involved in keeping different kinds of buildings comfortable.
Exactly.
So our mission today is to really dig into the facts that set these two apart. Let's dive in.
Yeah, sounds good. While the fundamental goal, heating and cooling remains the same, the scale, the complexity, and the demands placed on these systems in residential versus commercial settings, well, they lead to some fascinatingly different solutions.
Right.
Understanding these factual differences isn't just academic. It has real-world implications for everything from building design to, energy consumption.
Okay, so let's start with a really fundamental aspect, size and complexity. When you picture a home HVAC system, it's usually a fairly compact unit, often designed for a single family. What's the typical scope we're talking about there in terms of cooling power?
Well, in a typical single-family home, you'll generally find systems with cooling capacities ranging from about 1.5 to 5 tons.
Okay.
Now, when we say tons, just to clarify, it's a unit of cooling capacity, roughly equivalent to the amount of heat needed to melt 1 ton of ice in 24 hours.
Got it.
And these residential systems are often split systems, meaning they have a separate indoor and outdoor unit. They're usually based on standard, readily available designs.
Right, that gives us a good baseline. Now, when we shift our focus to commercial buildings, what kind of scale are we looking at in terms of their heating and cooling needs? It sounds like a whole different ballgame.
Oh, it truly is. Commercial HVAC systems operate on a much, much grander scale. Their cooling capacity typically starts around 5 tons and can easily go up to 50 tons or even, several hundred tons for very large structures like skyscrapers or shopping malls.
Wow, hundreds.
Yeah. These systems are designed to handle multiple zones within a building, each with potentially different temperature requirements, and they naturally have much higher power demands to manage these larger spaces and diverse needs.
So that higher demand probably means different electrical setups, too.
Absolutely. It often necessitates dedicated electrical infrastructure, which is a key factual difference from most residential setups.
It's a massive leap in capacity. And I imagine the physical setup is quite different, too. It's not just a bigger version of what you'd find at home, is it?
Not typically, no.
Oh.
While you might see smaller commercial spaces using split systems, maybe like a small shop, it's far more common to encounter packaged units. That's where all the heating, cooling, and ventilation components are integrated into a single outdoor unit, often placed on the roof.
Ah, the rooftop unit.
Exactly. We also see modular systems that can be expanded or reconfigured as a building's needs change over time. And quite frequently, commercial HVAC systems require custom engineering to precisely match the unique demands of the building's design, its occupancy, how it's used. It's a much more tailored approach compared to the more standardized solutions for homes.
Okay, so residential, smaller capacity, simpler design, often split. Commercial, significantly larger capacity, more complex, often packaged or modular, and frequently custom engineered. That sets a clear stage. Now let's talk about where these systems are actually located. For a house, it's usually tucked away, right? Basement, attic, maybe outside.
In residential buildings, yeah, as you mentioned, the HVAC equipment is usually placed in less frequently used areas like basements, attics, or, discreetly outside the building envelope. The goal is often to minimize noise and visual impact on the living spaces.
And when we look at commercial buildings, the image that immediately comes to mind is those large metal units sitting on flat roofs. Is that the primary location, and what's the thinking behind that?
Rooftop units, or RTUs, yes, they are indeed a very common sight on commercial buildings, and for good reason. Placing the HVAC equipment on the roof offers several practical advantages.
Right.
Firstly, it saves valuable interior space, which is always at a premium in commercial real estate.
Right.
Secondly, it can help isolate noise and vibrations away from the occupied areas, which contributes to a more comfortable indoor environment. And thirdly, it often provides easier access for maintenance and servicing. Technicians usually have unobstructed access without disrupting the building's occupants too much.
Okay.
That simplified access can be a pretty significant factor in the overall maintenance strategy, actually.
That makes a lot of sense from a logistical standpoint.
Yeah.
But being exposed up there, they're really at the mercy of the weather, aren't they? That seems like a potential drawback.
That's a valid point, yeah. The constant exposure to the elements sun, rain, snow, wind, it can indeed lead to accelerated wear and tear on the components of an RTU. Manufacturers do design these units to withstand harsh conditions, of course, but it's still a factor that needs to be considered in terms of maintenance and lifespan.
Now, we don't typically see these in homes, but you mentioned chillers and boilers earlier. Where do they fit into the commercial HVAC picture? Are they common?
Chillers and boilers are primarily found in larger commercial and industrial facilities. They are essential for providing the large-scale heating and cooling needed in systems that use chilled or hot water loops for air conditioning and heating distribution throughout the building.
So like big hospitals or campuses.
Exactly. Think large facilities. These are much more substantial pieces of equipment compared to the direct refrigerant-based systems common in homes and are, rarely, if ever, found in residential settings.
Okay. Different systems for different scales. Now, one thing I've heard about in commercial buildings is the ability to manage the entire climate control system remotely, like from a computer somewhere. What's the technology behind that?
You're talking about building automation systems or BAS and direct digital control or DDC systems.
BAS and DDC.
Okay. These are sophisticated control networks implemented in commercial buildings to monitor and manage various building systems. HVAC, lighting, security, often all integrated.
Wow.
For HVAC specifically, they allow for really precise control over temperature, airflow, and ventilation in different zones. Plus, scheduling operations based on occupancy, optimizing energy usage.
So super efficient.
Potentially, yes. This level of granular control and automation is a key factual difference from the simpler thermostats found in most homes. These systems can even provide data-driven insights to predict potential maintenance needs, which further enhances their value in commercial building management.
So it's like a highly advanced, building-wide smart thermostat, but with a lot more intelligence and control built in.
That's a good, simple way to think about it, but it's far more intricate, allowing for complex programming, data logging, and integration with other building systems.
Which probably means installation's more complex too.
Definitely. That level of sophistication introduces different installation challenges. Accessibility to install and maintain these complex networks, the physical space required for controllers and wiring, and even adherence to specific zoning and building codes related to these systems, these all become important considerations in commercial projects, often much more so than in residential installations.
Right. It's definitely not just plugging in a new thermostat. Okay, let's shift gears to keeping these systems operational. Maintenance and repairs. For a homeowner, it often involves like changing air filters every few months and maybe an annual service check. What does that look like for commercial systems? Sounds more intense.
Oh, yeah. The realm of commercial HVAC maintenance is significantly more demanding. Given the size and, frankly, the critical nature of these systems for business operations and occupant comfort.
True. Can't have the office freezing or boiling.
Exactly. So they require specialized technicians with expertise in handling complex commercial-grade equipment. Routine maintenance contracts are very common, and the overall approach is much more proactive and preventative.
Proactive in what sense? What are some of the specific maintenance tasks that are more critical or maybe more frequent in commercial settings?
Well, think about the sheer volume of air being circulated in a commercial building, with potentially hundreds or thousands of occupants.
Right.
This means air filters can become clogged much, much more rapidly. While a homeowner might change their filter every, say, 1 to 3 months, a commercial facility might require filter changes on a weekly or biweekly basis just to maintain air quality and system efficiency.
Exactly. Wow.
Yeah, depending on the environment. And similarly, instead of maybe a single annual checkup, commercial HVAC systems often undergo quarterly or even biannual inspections that are far more comprehensive. We're talking detailed checks of all components, performance testing, preventative maintenance tasks to identify and address potential issues before they lead to breakdowns.
So it's more frequent, more thorough, and requires specialized skills. That must translate to a significant difference in maintenance and repair costs compared to residential.
Absolutely. The costs associated with both routine maintenance and repairs for commercial HVAC systems tend to be considerably higher.
Makes sense.
The replacement parts for commercial-grade equipment are often more specialized and expensive, and the labor requires highly trained and certified technicians, which also factors into the cost. Plus, you need to consider the potential financial impact of system downtime in a commercial setting.
Yeah. Good point.
Like we touched on earlier, the failure of a key component, say a compressor, can lead to significant disruptions affecting productivity, business operations, tenant satisfaction. It can result in actual revenue loss. This makes that preventative maintenance even more critical in the commercial sector.
That really highlights the stakes involved. Okay, now let's move on to something that impacts the comfort and health of everyone indoors. Ventilation and air distribution. In a typical house, the ductwork is relatively simple, right? Serving the main living areas. How does that compare to a commercial building?
Well, commercial buildings typically feature far more intricate and extensive multi-zone ductwork systems. These systems often incorporate something called variable air volume, or VAV, boxes.
BAV boxes.
Yeah. They allow for independent control of airflow and temperature in different areas or zones within the building. This enables customized comfort levels and energy efficiency by delivering conditioned air only where and when it's needed.
Ah, so it's a much more sophisticated way of delivering air rather than just a uniform flow throughout the building like in most houses.
Precisely.
And with a higher density of people in commercial spaces, offices, stores, whatever, the need for fresh air must also be significantly greater, right, for air quality.
Exactly. Building codes and standards, particularly those set by HRA, that's the American Society of Heating, Refrigerating, and Air Conditioning Engineers.
Okay, AirShow.
They mandate much higher rates of fresh air ventilation per occupant in commercial buildings compared to residential homes. This is crucial for maintaining good indoor air quality, diluting pollutants like CO2 or VOCs, and just ensuring a healthy environment for a larger number of people crammed together.
I've also heard about commercial buildings using outside air for cooling when the conditions are right. How does that work? Is that something we see in homes?
That involves the use of economizers. These are devices integrated into commercial HVAC systems that can bring in and utilize outside air for cooling when the outdoor temperature and humidity are favorable.
So like on a cool spring day instead of running the AC.
Exactly. It just brings in the cool outside air. This free cooling strategy can significantly reduce the reliance on mechanical refrigeration, leading to substantial energy savings, especially during those milder shoulder seasons.
Interesting. Why aren't they common in homes then?
Well, economizers are less common in residential systems, mainly due to the generally simpler design and lower overall energy consumption relative to commercial buildings. The payback just isn't always there on a smaller scale.
Gotcha. And what about makeup air units? I don't think I've ever encountered that term in a residential context. What are they and what do they do?
Good question. Makeup air units, or MAUs, are often essential components of commercial HVAC systems, particularly in buildings with significant exhaust requirements. Think restaurants with kitchen hoods, industrial facilities, hospitals, labs.
Places exhausting a lot of air.
Right. These units are designed to draw in fresh outside air, filter it, and sometimes condition it, heat or cool it slightly to replace the air that is being exhausted from the building.
Why is that important?
It ensures a proper balance of air pressure within the building, preventing negative pressure issues, and it helps maintain indoor air quality by bringing in that fresh, filtered air. Makeup air units are typically not necessary in residential buildings, which generally have much lower exhaust volumes and rely more on natural infiltration, little leaks, for fresh air exchange.
Right. And I suppose things like humidity control are also more critical in some commercial settings.
Oh, definitely. The precise control of air quality and humidity is often far more critical in specific commercial environments, like clean rooms, data centers, museums, or healthcare facilities, than in a typical home.
Okay, that gives us a much clearer understanding of the complexities involved in managing air in commercial spaces. Now let's talk about the rules and regulations that govern these systems. I imagine there are more stringent requirements for large commercial buildings.
You're absolutely correct. Commercial HVAC systems operate under a much more rigorous regulatory framework. They have to adhere to strict building codes that govern design, installation, safety. It's quite extensive. Additionally, OSHA, the Occupational Safety and Health Administration regulations, apply to ensure the safety of workers during installation, maintenance, and operation.
Right. Worker safety.
And energy efficiency regulations are also typically more stringent for commercial buildings, aiming to reduce overall energy consumption. Furthermore, environmental regulations, like those from the EPA, concerning the handling and phase-out of certain refrigerants, like the old R22.
Oh, yeah, the freon phase out.
Exactly. Those rules are often more heavily enforced in commercial applications, just due to the larger quantities of refrigerants involved and the potential environmental impact if things go wrong.
And for homeowners, what's the regulatory landscape like? Is it mostly just local building codes?
Primarily, yes. Residential HVAC systems are subject to local building codes and safety standards, but the level of complexity and the number of regulatory bodies involved are generally fewer compared to commercial systems.
And what about the professionals who work on these systems? Are their qualifications and certifications different for commercial versus residential work? I'd assume so.
Yes, there can be significant differences in the required qualifications and certifications. Many jurisdictions require commercial HVAC technicians to hold specific licenses and certifications, such as those offered by organizations like NATE North American Technician Excellence or HVAC Excellence.
Okay.
These certifications demonstrate a higher level of competency in working with the more complex equipment and sophisticated control systems, like those BAS systems we talked about, found in commercial buildings.
Right.
While residential HVAC work may also require licensing in some areas, and, in certain instances, homeowners might even be able to undertake some basic tasks themselves with the necessary permits.
Mm-hmm.
The requirements for commercial work are generally much more stringent. It reflects the complexity and the potential risks associated with these larger and more intricate systems.
That makes perfect sense. You'd want highly skilled and qualified individuals working on those complex, expensive systems. All right, let's talk about the financial aspects, the initial costs, and the typical lifespan of these systems. What kind of investment are we looking at for each? Big difference, I bet.
Oh, yeah. The initial investment cost vary dramatically. A typical residential HVAC system installation might range from around, say, $5,000 to $15,000, depending on the size, the brand, the efficiency of the unit.
Okay, that's a significant home expense.
It is, but for commercial HVAC systems, the costs can start in the tens of thousands of dollars and easily exceed $100,000 or even much, much more.
Well, 100 LEK plus.
Easily, depending on the size of the building, the complexity of the system design, maybe needing custom engineering and any specialized installation requirements like craning those big RTUs onto a roof or running extensive complex ductwork.
That's a substantial difference in the initial outlay. But what about how long these systems tend to last? Does the bigger investment in commercial units translate to a longer lifespan?
Generally speaking, yes. Commercial HVAC systems are often built with more robust industrial-grade components. And due to the necessity of that regular professional maintenance we discussed,
Like the proactive approach.
they can have a longer lifespan than residential units. While a typical residential system might last, 10 to 15 years on average,
Mm-hmm.
a well-maintained commercial system can often operate effectively for 15 to 25 years, and sometimes even longer, with really diligent care and timely repairs.
So consistent maintenance is key to maximizing the lifespan for both types of systems, really.
Absolutely. Regardless of whether it's a residential or a commercial HVAC system, regular and proper maintenance is crucial for ensuring optimal performance, preventing premature failures, and extending the system's useful life. Neglecting maintenance can lead to significantly reduced efficiency and eventually costly breakdowns in both scenarios.
And that leads to the repair versus replace question.
Exactly. And the economic analysis for that decision will differ based on the age, condition, and energy efficiency of the existing system, as well as the extent and cost of the necessary repairs. It's often a more complex calculation for a large commercial system.
Now, energy efficiency is a major focus these days, obviously. How does that factor into the considerations for commercial versus residential HVAC systems? Is it a bigger deal for businesses?
It often is, yes. Energy efficiency is frequently a much more critical driver in the design and operation of commercial HVAC systems. You have to remember, HVAC can account for a very significant portion, often 40 to 60% of a commercial building's total energy consumption.
40 to 60%. That's huge.
It is. Therefore, businesses have a substantial financial incentive to invest in energy-efficient technologies and practices. You see initiatives like LED certification leadership in energy and environmental design and just general investments in high-efficiency HVAC upgrades being much more prevalent in the commercial sector. These are often supported by potential tax benefits and, of course, the promise of significant long-term savings on massive energy bills. While energy efficiency is also important for homeowners, the sheer scale of energy usage in commercial buildings means that even relatively small improvements in efficiency can result in substantial cost reductions over time.
Right. Those savings can really compound on a larger scale. Well, we've certainly covered a lot of ground today, delving into the factual distinctions between commercial and residential HVAC systems, from size and complexity to installation, maintenance, ventilation, regulations, costs, and lifespan. It's clear that while they share the fundamental purpose of climate control, they are really quite different beasts.
Indeed, they are. The factual differences are significant and really reflect the unique demands and priorities of each application, the home versus the large commercial space. A clear understanding of these distinctions is, I think, invaluable for anyone involved in the design, ownership, management, or servicing of these critical building systems.
Absolutely. So as we conclude this deep dive into the factual world of commercial and residential HVAC, let's maybe leave our listeners with a thought. Given the immense scale and intricate engineering involved in commercial climate control, what cutting-edge innovations do you anticipate will have the greatest impact on how we heat and cool our larger buildings and shared spaces in the years to come? It's definitely a fascinating area to contemplate. Thanks for joining us for this enlightening deep